The James Webb Space Telescope, humanity's most powerful eye on the cosmos, has revealed something astonishing. During its latest observations, it recorded faint but persistent glows coming from a planet nearly 4 light-years away, Proxima Centauri b, the closest known exoplanet to Earth. What Webb detected is unlike the usual atmospheric flickers or random bursts of radiation. These glows appeared in repeated pulses, their brightness rising and falling in a rhythm far too organized to resemble natural phenomena. Instead of scattered light from auroras or volcanic eruptions, these emissions follow a pattern that hints at intelligent design. Proxima Centauri b orbits our nearest stellar neighbor, a small red dwarf star called Proxima Centauri in the Alpha Centauri system. This rocky world lies in the so-called habitable zone, where temperatures could, in theory, allow liquid water to exist. Astronomers have long considered it one of the most promising places to search for life beyond our solar system. Yet until now, no clue this striking had ever emerged. Unlike Earth, Proxima b is believed to be tidally locked, one side locked in perpetual daylight, the other in endless night. If life evolved there, especially in advanced civilization, it might have had to compensate for the eternal darkness of its night side. Artificial lighting would be one logical solution. Webb's instruments have detected faint but consistent infrared emissions from that very hemisphere, a signal that could resemble urban illumination seen from orbit. The data show brightness levels fluctuating with a regularity reminiscent of power grids or cities cycling through nighttime energy use. Some scientists, like Columbia University's David Kipping, have expressed cautious excitement. This isn't simply a telescope glitch, they say. It's something that deserves very close scrutiny. To unravel this mystery, we have to understand the environment. Proxima Centauri, a small but active red dwarf, frequently blasts nearby planets with flares capable of stripping atmospheres. If Proxima b still holds a dense atmosphere, it would have to be unusually resilient, and that same atmosphere could, in theory, support life or even advanced technology. Webb's infrared sensors can also identify chemical signatures in exoplanet atmospheres. In the case of Proxima b, the telescope has recorded an odd mix of gases, high methane concentrations with unusually low carbon monoxide levels, a ratio hard to explain through ordinary geology or chemistry alone. On Earth, methane at that scale is mostly linked to living organisms or industrial processes. This leaves several possibilities. We could be seeing the byproduct of a thriving biosphere. Or perhaps an industrial civilization shaping its own environment. Another scenario. These lights aren't cities at all but something more ambitious, giant orbital mirrors illuminating the dark side, massive solar arrays, or even beams of directed energy used as interstellar beacons. We must also remember natural explanations. Could these glows come from volcanic vents, surface luminescence, or some yet unknown planetary process? While possible, the regularity and stability of the signals make that hypothesis difficult to reconcile. Detecting such faint emissions is a triumph of technology. Webb's coronagraph can block starlight and pick out dim planetary light billions of times fainter than its star. Even more advanced instruments are on the horizon. NASA's planned Habitable Worlds Observatory and the Starshade concept could soon capture direct images of Earth-sized planets in unprecedented detail. Ground-based giants like the Extremely Large Telescope, expected to start operations later this decade, may confirm whether these glows on Proxima b are truly artificial. If the signals are what they appear to be, the implications are almost beyond comprehension. We would be staring at the first direct indication of another intelligence, not a radio whisper from the edge of a galaxy, not a statistical anomaly buried in data, but a clear, persistent glow on the closest known exoplanet. Only 4.24 light-years away. Close enough that, if they have been watching the sky as long as we have, they could already know our world by name. What kind of society might exist there? Perhaps a people who have endured the fury of their red dwarf star for millennia, evolving under relentless radiation storms until only the hardiest life survived. Perhaps engineers who burrowed deep beneath their planet's crust, building vast subterranean cities powered by geothermal energy and illuminated by synthetic suns. Or maybe they are explorers, not unlike us, who raised their eyes to the dark and began building technologies to reach out across the void, sending faint signals as an invitation or a test. Discoveries like this stand at the very crossroads of science, philosophy, and imagination. They force us to question the assumptions we take for granted about life, about intelligence, and about our place in the cosmic order. For decades, the search for extraterrestrial life was a mostly theoretical exercise, a thought experiment playing out in radio telescopes and computer models. Now the James Webb Space Telescope may have pushed that speculation into reality, handing us a data set that refuses to be ignored. Skepticism is essential. Extraordinary claims demand extraordinary evidence. Every potential explanation must be examined. Instrumentation errors, exotic but natural phenomena, or even patterns our own minds impose on random noise. Yet, even with those caveats, the Webb data marks a turning point. It has cracked open a door into a new chapter of the search for life beyond Earth. A chapter that feels far less like speculation and far more like a conversation waiting to happen. Even if these strange glows ultimately prove to be geological, atmospheric, or something else entirely natural, their mere existence reshapes our expectations. The universe no longer seems like a distant, indifferent backdrop. It feels alive with possibilities, a place where even a nearby world can send out glimmers bright enough to awaken the hopes of an entire species. And if, against all odds, the lights on Proxima Centauri b are truly artificial, then history has already changed. It would mean that we are not the first to cross the threshold of technological civilization in our cosmic neighborhood. That someone, or something, has already walked this path, endured its challenges, and now shines a signal across the night. If that is the case, then maybe, just maybe, they've already said the words our species has longed to hear since the first humans looked up at the stars. We are here. And you are not alone.